What's up everyone, Patrick here, welcome back. And in this particular question, what we have to do is we have to find the equation of the right bisector given the endpoints of each line over here, of each of these line segments. So we're given the endpoints of the lines, we're gonna have to find the equation of the right bisector. Now, just as a general overview, what is a right bisector? So if we have the endpoints of a line, let's say that we join that up. What's the right bisector going to be? Well, it's going to be a line that cuts this line segment in half, right? Bisects it. That's what that means. Cuts it in half, and it cuts it in half with a line that's perpendicular to this line. So if this is the midpoint, then it's going to be a line like that. Right, that cuts it in half, and then it's perpendicular to the line segment. So, for example, for this, we're going to be given -2 and 5, and then 10 and -7. By the way, this is not to scale, so I know that the y value here is below this y value, so it's actually going to be a downward sloping line, but just kind of showing you a general diagram so you see where we're going. So we're given the endpoints for all of these questions, and we have to find the equation of this line over here. And so if we create some general steps here that we can undertake no matter what endpoints we're given, well, how would we find the equation of this line? This is a line, so it's going to be in y equals mx plus b form. It could also be in standard form, ax plus by plus c is equal to 0. So for all of these, I'll also give the standard form line. But just in general, what are the steps? If we're given the endpoints, we've got to find the equation of this line. How can we get to that? Well, notice that we're going to have to get the slope of this line. How can we do that? Well, we could first find the slope of the line segment. So we find the slope of line segment, which would be this slope over here. And then once we have that slope, we know that this slope is going to be perpendicular to this line. And if two lines are perpendicular, that means that the slopes are negative reciprocals of one another. So if one line, for example, has a slope of 2/3, then a perpendicular line is going to have a slope of -3/2. We would just flip this and change the sign. Or let's say we had a slope of 4/5, then a perpendicular line would have a slope of -5/4. Or you might even just get numbers. So let's say a line had a slope of 2. Well, this is like 2/1. So a perpendicular line would have a slope of -1/2. Right? You just change the sign and then flip it. So that's what we would do in step 2, is we would find the perpendicular slope, which is going to be a very easy step because we just take the slope that we found in step 1 and then we find the negative reciprocal of that. However, at this point, we're just going to have the slope of the line. But that's not enough to get an equation of the line. So we're also going to need a point on that line. Well, what's the point going to be? The midpoint between the endpoints that were given of the line segment. So then we could find the midpoint of the line segment. So now we're going to have the slope of this line, which we found in step 2, and then the point, a point on that line, which is going to be the midpoint of the line segment found in step 3, and then we could find the right bisector in step 4. Then it just becomes a case of having the slope of a line and then the coordinates of a line, and then just finding the equation of that line like we've done in many videos before. So for all of these are the general steps that I'm going to be following. So let's start off with part A. We have -2 and 5, 10 and -7. So the first thing I'm going to do is find the slope of that line segment. So let's label these x1, y1. This would be x2, y2. So we'd have y2 minus y1. So we'd have -7 minus 5. Be careful with your signs here. So this minus that. Then we'll have 10 x2 minus x1, which would be -2. Again, it doesn't matter if you label this x2, y2, and then this x1, y1. Overall, if you do it that way, then you're going to get the same slope. So in this case, what is the slope here? It's going to be -12 over, this would be 10 plus 2, which would give us +12, which would give us a slope of -1. So that's the slope of the line segment. Now in step 2, we're going to find the perpendicular slope, which would be the negative reciprocal of this. So this -1 is like over +1. So we flip this, which would just be 1 over -1, and then we change the sign. So since it's a negative here, the perpendicular slope is going to be positive. So it end up being +1 over 1, which is just 1. Right? Whenever you get a slope of -1 or +1, the perpendicular slope is also going to be 1, but with the different sign. Okay, so the slope of the line that we're actually finding is going to be 1. It's not -1. We got to find the perpendicular slope, which is +1. Okay, so we have that. That was step 2. Now step 3, we got to find a point on the line, which is going to be the midpoint between these 2 points. So the midpoint would be the sum of the x values divided by 2, and then the sum of the y values divided by 2, like that. So -2 plus 10 would give us 8, divided by 2 would give us 4. 5 plus -7 would give us -2, divided by 2 would give us -1. So the midpoint is 4 and -1. And now we have a point and a slope. We could find the equation of the line. So different ways to find the equation of a line. You could use y equals mx plus b, which is what I use. You could also use y minus y1 equals m bracket x minus x1. That's another way your particular teacher may do it. Just make sure whatever equation that you get with your particular way, you're getting the same equation that I'm going to get. So y equals mx plus b, plug in 1 for the m, so it's just an x here, like that. It's like 1x. So now we could plug in 4 for x, and then -1 for y, and solve for that b value. Bring the 4 over. -1 minus 4 would give us -5. So the final answer in this case is y equals 1x, or x, minus 5. That is the equation of the right bisector for a line segment with those endpoints. That's the process right there. If we want to take that line, put it in standard form, this is already positive, so bring the y over. We'd have x minus y minus 5, like that. So that's another format the line can be given in. Right, so each of these, that's the answer for part A. Now moving on to part B, same steps. So first step, we have to find the slope between these points. So we'd have x1, y1, x2, y2. So the slope of this line segment would be y2 minus y1, like that. And then we'd have x2 minus x1. So we'd have 4 minus -5, like that, which would be -1 plus 6 over 4 plus 5, right? Positive, positive, 2 negatives. This would be +5, and then this would be 9. So that's the slope between these 2 points. Now to get the slope of the right bisector, we got to take the negative reciprocal of that. So we would flip it and then put a negative there. So negative 9 over 5 is going to be the slope of the right bisector in this case. Next, we need a point on the line, so we'd find the midpoint between these. So we'd have negative 5 plus 4 over 2. Add up the x values, divide by 2. Add up the y values, divide by 2. So this would end up being negative 5 plus 4 is negative 1 over 2 is just negative 1 over 2. Negative 6 plus negative 1 would be like negative 6 minus 1, which would be negative 7, and that's going to be over 2. So that ends up being the midpoint that we're going to be working with. So now we just have to find the equation of a line with this point and then that slope. It just becomes a general question like that. So from here, we'll have y equals mx plus b. So we know the slope is negative 9 over 5. And then we plug in the y value of the midpoint, then the x value of the midpoint. Just be careful with your algebra over here. So we'll have negative 7 over 2 equals negative 9 times negative 1 is positive 9. 5 times 2 is 10. Then we'll have plus b like that. And then bring this over. So then the b value is basically going to equal negative 7 over 2 minus 9 over 10, right? This is a positive. When we bring it over, it becomes a negative. So now get a common denominator between 2 and 10 would be 10. So we'd multiply this by 5, multiply this by 5. So we'd end up with negative 35 over 10 minus 9 over 10, which would give us negative 44 over 10. And then notice this simplifies to negative 22 over 5 like that. Right? So just being careful with the algebra with all the steps. Stay very aware at these points. So this is the b value, and then that's the slope. So the final equation of the line is going to be y equals negative 9 over 5x minus 22 over 5. Okay, that ends up being right there the answer to part B. That's the equation of the right bisector. If you want to put it in standard form, get rid of the fraction so we can multiply everything by the lowest common denominator, which would be 5. So multiply this by 5, multiply this by 5, multiply this by 5. So 5 times y is just 5y. These 5's cancel out, so we'd have negative 9x. These 5's cancel out, so we'd have negative 22. And we want to put everything on the side where the coefficient in front of the x is going to be positive, so bring everything to the left side in this case. So we'd have positive 9x plus 5y. Bring that over, it becomes plus 22 equals 0. So that's another form that the line can be in. Right? So that ends up being the answer for part B. And then finally, part C. This one you got to be careful with because we have fractions. Same exact process is going to apply. It's just there's going to be a little bit more to be conscious of when we are doing the algebra. So let's label these like usual. We'll have x1, y1, x2, y2. So the slope is going to be y2 minus y1. So we're going to have negative 7 over 3 minus 1 over 2 all over x2 minus x1. We're going to have 2 over 5 minus negative 3 over 4. Like that. Now from here, what I recommend doing, you can simplify in this format, but personally whenever I have fractions within fractions, just to not get too messy, I like to work with the numerator and the denominator separately. So first, working with the numerator, I'm going to do negative 7 over 3 minus 1 over 2. What's the common denominator between 3 and 2? 6. So multiply this by 3, multiply this by 3, this by 2, this by 2. So we'd end up with negative 14 over 6 minus 3 over 6, which would give us negative 17 over 6, like that. So that's what the numerator simplifies to. So we're going to end up with negative 17 over 6 over here. And then we're going to have 2 over 5 minus negative 3 over 4. That's just plus 3 over 4, right? Those two negatives turn into a positive. So 20, common denominator, multiply this by 4, multiply this by 4, multiply this by 5, multiply this by 5. We'd have 8 over 20 plus 15 over 20, which would give us 23 over 20, like that. So that's what the denominator simplifies to. So this we could plug in over here. And now it's just simply of taking one fraction and dividing it by another fraction, like that, which would be like taking a fraction, multiplying it by the reciprocal of that right there. And then from here, you can multiply these out, but what I like to look for is stuff that could simplify. So notice the 20 over 6 simplifies. So we could put 3 here and then 10 there, right? 20 over 6. Doesn't have to be 20 over 23 you simplify, though you should look for that if it could simplify. But you could take negative 17 over 23, simplify that, or 20 over 6 because you're multiplying. So it doesn't matter which order you put it in. 20 over 6 simplifies to 10 over 3. And then from here, you can just multiply these. Negative 17 times 10 would give us negative 170 over 3 times 23 would give us 69. Okay, so that right there ends up being the slope of this line segment. Okay, so let me write that over here. Negative 170 over 69. So we can't use that slope. We need the perpendicular slope. Right, so step 2, what's the perpendicular slope to this? Well, we would flip it, 69 over 170, and then change the negative to a positive. We would change the sign. So that's the slope that we're going to be using. Now what we need is the midpoint. So to get the midpoint, what we're going to do is we're going to add up the x values divided by 2, add up the y values divided by 2. Okay, so lots going on here, lots of algebra when you get fractions like this. So just be really careful with your steps here. See, even me right now, I just screwed up. This was negative 3 over 4. Right, negative 3 over 4 plus 2 over 5, 1 over 2, plus negative 7 over 3 over 2. Okay, so you got to be really careful here. Maybe each step, go back and check. That's personally what I like to do, is when I'm working with a lot of fractions like this, is try to be checking as many steps as possible. It does take a little bit more time, but in the end it saves you time because you don't have to go back and correct things. So from here, let's work with this numerator separately. Common denominator would be 20. Right before we were subtracting these, now we are adding them when we're working with the midpoint. So negative 15 plus 8 would give us negative 7 over 20. So this negative 7 over 20, that ends up being this numerator over here. So what we got to do is we got to now take the negative 7 over 20 and we got to divide it by 2. Right? This is negative 7 over 20. We have to divide it by 2, which is like dividing it by 2 over 1, which is like multiplying it by 1 over 2. So this would end up being negative 7 times 1 is negative 7, and then 20 times 2 would give us 40. And then negative 7 over 40, that doesn't simplify any further. So the midpoint ends up being, the x value rather of the midpoint ends up being negative 7 over 40. And then following the exact same process here, so let's work with this numerator first. So we'll have 1 over 2 minus 7 over 3, multiply this by 3, multiply this by 3, multiply this by 2, multiply that by 2. The common denominator is going to be 6. So we'll have 3 over 6 minus 14 over 6, which would give us negative 11 over 6, right? Looks good to me. So this negative 11 over 6 is that bracket. And then we got to take that and divide it by 2, which is like multiplying it by 1 over 2, which would give us negative 11 over 12. Okay, so this ends up being negative 11 over 12, like that. And now, finally, we have a point and then a slope. So from, just give me a sec here. Yeah, from here, we just find the equation of this line. So pretty large fractions that we're dealing with, we can't simplify them any further, unfortunately. So we would have y equals 69 over 170x plus b. So the y value would be negative 11 over 12. And then the x value we're plugging in is negative 7 over 40, like that. And then we're going to have plus b. And when you multiply these fractions over here, so 69 times negative 7 gives us negative 483, then 170 times 40 gives us 6,800. This doesn't simplify any further. And so what you want to do now is just isolate for this b value, so you would bring this over. So basically the b value would be negative 11 over 12 plus 483 over 6,800. When we bring this over, it becomes a positive. Right? So pretty big fractions that we're dealing with. When I made this, I didn't realize that the fractions were going to be so big, but it's good practice for the algebra. So what would be the common denominator between 12 and 6,800? Now 6,800 actually doesn't divide by 12 smoothly. And so what you could do is you could keep multiplying the 6,800. So, or you could keep adding 6,800. So 6,800 times 2 would give us what? 13,600. But 13,600 doesn't divide by 12 smoothly. And then add another 6,800. So the next would be 2,400. And then if you take this and divide it by 12, that actually gives us 1,700. So it gives us a smooth number. So this 2,400 could be the common denominator. So we can multiply this by 3, multiply this by 3, and then 12 we can multiply by 1,700, multiply this by 1,700. Now if you don't want to go through this process, what you can just do is you can, worst case scenario, if you're having trouble finding a common denominator, you could just multiply these two for the common denominator. So if we rewrote this, right, we could just multiply this by 12, this by 12, and then we could just multiply this by 6,800, this by 6,800. When you multiply those, I don't know what that denominator is going to be. It's going to be larger than the 2,400 that we're going to use. So you could do it this way. It's just then you're going to have more simplifying to do at the end, right? If you don't find that lowest common denominator. But if you're working with big numbers like this, sometimes going this route might be better, especially if the numbers are like really complex. So 12, 6800, those are kind of like nice smooth numbers, but what if this was like 6,800 and I don't know, let's say 22, you know, and this was like 123. Then it could start becoming a bit of a burden, and then it might just be worth it to go this way, right? But I'm going to stick to this over here. So what's going to happen is we would have negative 11 times 1700. That would give us what? 17,000 plus 1700, which would give us 18,700, like that. That's going to be over 2,400, like this. And then this here would end up being 1,449 over 2,400, like that. And then when you net those out, when you net the numerator out, you'd end up with negative 17,251 over 20,400, and then that doesn't simplify any further. So that ends up being the B value. So fairly intense line. I doubt you'll get a question like this. So it's good practice, because this is pretty much as tough of a right bisector that you would have to find. Right? So y equals mx plus b. Now, if we want to put it in standard form, what we would do here is we would find the lowest common denominator between 170, and then 20,400. And luckily, actually, the lowest common denominator between these would be the 2,400, because 2,400 divided by 170, that actually gives us a smooth number. It's actually 120. So we can multiply everything by 2,400. Multiply this by 2,400. And then this would end up being 2,400y equals, now 170 goes into 2,400 120 times. And then 120 times 69 would give us 8,280. This would be x. These cancel out, so we're just left with a minus 17,251 over here. And then notice the x is positive here, so bring everything to the right side. These are crazy numbers, I can't lie. Can't believe nothing simplifies here. But that's actually it right there. Right? So that is the standard form line of this right bisector. So it could be in this format or this format. Right? So pretty much as intense of a right bisector question that you're going to get for part C. Usually it won't be like that. It'll simplify nicer. I just picked random fractions, so it ended up being like that. But same process applies for all of these, no matter how big the numbers you are that you're dealing with. So you first find the slope of the line segment that you're given, find the perpendicular slope, find the midpoint, and then use the perpendicular slope and the midpoint to find the equation of the line or the equation of the right bisector.